Welcome on this tutorial. Wish all you are well. Here I will discuss about P&ID, which is piping and instrument diagram or process and instrument diagram. P&ID is based on process flow diagram. I have already discussed about process flow diagram and piping and instrument diagram basic on a separate tutorial. If you haven't seen it, please see it. To read process flow diagram and P&ID, we need to know the symbols of different equipments and different instruments. Here I will discuss in details about different symbols used to identify different piping equipment and instruments. Please subscribe my channel, it will help me to get platform and also you will get time to time notification. P&ID is piping and instrument diagram and it is also called process and instrument diagram. P&ID is a graphical representation of the process system that include the piping, vessels, control valves, instrumentation and other process equipment and components. P&ID is the primary drawing which is used for laying out the process control system. P&ID is developed based on the process flow diagram. The process flow diagram is more general flow of process and the relationship between major equipment of a plant. Reading process flow diagram and piping and instrument diagram is nothing but reading the different symbols. So we need in-depth idea on different symbols of equipment and instruments. Symbols are set of diagram which shows interconnection of process equipment and instrument used to control the process. Symbols are standardized by International Society of Automation with the standard S5.1, ISO 14617-6 and ISO 10628. These symbols are also labeled with words, letters and numbers to further identify and specify the components that are representing. This is reference symbols related with pipe. There is a main process symbol having a thick line. This is thermally insulated line. This symbol of jacketed line. This symbol of electrically heated line. This is stressed heated pipe. This is flexible pipe. This is instrument impulse or instrument pipe. In P&I diagram, the pipes are identified by the specific type of tag number. This tag consists of size, service, unit number, pipe class, insulation tracing, circuit number, etc. So this is one example of pipe identification. 3 inches P121007 A11A H30. Now what is the meaning of this? Say 3 indicates the line size, it is 3 inches line size. P indicates the fluid service, which type of fluid is flowing through the pipeline. 12 signifies the unit facility number. Unit facility number means number of area in a particular process plant. 1007 denotes the serial number. A11A is pipe service class which is mandatory but it again depends on the project to project. A denotes the flange range. In this figure there is a flange just like a wheel. Using this flange the valves or other pipes might be connected. 11 denotes the piping material, which type of material is used. A is a suffix qualifying the piping material. H indicates the type of insulation, here it is hot insulation, and 30 denotes the insulation thickness. There are different types of insulation. This might be cold insulation, might be safety insulation, might be acoustic insulation, might be personal protection. There might have different types of tracing, electric tracing, steam tracing, chill water tracing, thermal or hot oil tracing. These different tracings are normally used to maintain the temperature of the fluid inside the pipe. This is pipe crossing over pipe. Two pipes, one is placed on the another one but they are not connected. Whether they are connected or not connected, that is differentiated by this type of symbols. The older convention is that this is connected, this is not connected. For the case of not connected, there is a hump. For newer convention, connected is defined by the dotted at the crossing section. Not connected, no dot point is here. There is another convention, the pipes which are not connected might be defined by this symbol or by this symbol. Pipeline breaks. When two types of pipes are connected, there is a break and that break is identified by a very small rectangular shape. So whenever we will see this type of rectangular shape, we can identify that there is a line break. Means this is line number 1, this is line number 2. Line number 1 having a particular thickness or particular line size, line number 2 having different property. Here also a triangular shape is there, so there is a line break also. Here there is a line break also. Different types of valves are there. Here I will discuss about the symbols only. This is the two-way valve. This is again two-way valve. This is unidirection, but this might be the both direction. This is three-way valve. This is four-way valve. This is a symbol of ball valve. This is symbol of gate valve. This is symbol of globe valve. This is symbol of butterfly valve. This is check valve, pressure relief valve. This is pressure reducing valve. This is angle valve, plug valve, pinch valve, needle valve, diaphragm valve. We will study later about the different functions of different valves. Here is the valve actuator. All the symbols are having single type of valve. All are ball valve having different type of actuator. Here a handle is there at the top. This is manually operated valve. This is pneumatic operated diaphragm valve. This is rotary piston type pneumatic actuator. This is written M, so this is electrical motor actuator. This is written H, this is hydraulic actuator. This is solenoid operated actuator. This is different connection, how the valves are connected with the pipelines. This is flange type. Already we have seen the flange. So the valve is connected with flange. This is one vertical line on vertical line at the outer side. So these are two flanges at left side and right side. Valve is connected with these flanges. This is thread connected, means the valve is connected with a thread. This is socket welded, this is butt welded, both are welded. Now here is a figure I have shown here. This is socket welded, means the pipeline is inside the valve body, and this is butt welded, means diameter of these two parts are same. Somewhere in the valve symbol we may see different words are written there, like NO, FO, CSO, like this. NO is normally open, it means that at normal condition it is open. When the signal will be given, it will start to close. NC is normally closed. FO is fail open. Fail open means when control valve will get no signal from the controller, it will remain in open condition. And this is the reverse, that is fail to close, means no signal from the controller, it will be in closed condition. This is CSO and CSC. This is card seal open and card seal closed. CSO and CSC are for lock or seal the valve to open or close position to prevent unauthorized operation of valve. There are different pumps and compressor symbol. This is horizontal pump, vertical pump, sump pump. There are different compressor, positive displacement, progressive cavity, screw pumps, vacuum pump, etc. There are the different symbols of drums or vessels. Here are the symbols of distillation tower. These are symbols of different piping components. It is not possible to explain everyone, so please pause the video and see the symbols. Next, coming related to instrumentation symbol. This is the symbols of instrument signals. The dark line represents piping through which the process stream flows. The process stream could be gas, liquid, or any type of mixture of phases. A more light line connects a piece of hardware to the process line or a piece of processing equipment. This might be called minor process lines. The break lines are the symbol of electrical signal, say for 4 to 20 mA signal. This symbol is pneumatic signal, say 3 to 15 psi signal. This is for data link. Data link means the data with 0 and 1, means digitized data. This is for capillary tubing for field system. This is for hydraulic lines. This is for guiding electromagnetic or sonic signal. Next, these are the different symbols of instrument bubbles. This is just a circle which indicates the discrete instrument, and this is normally located in the field, and if the instrument having a display, that is only accessible locally. There is a circle inside the square. This shared instrument, this might be function as a display or as a controller or both. Hexagonal shape, this is a computer function, this acts as a controller. Diamond shape inside the square is the symbol of programmable logic controller. Now coming to rest part. In this 4 column, the shape having solid line as well as having dashed line. This is single solid line, this is single dashed line, double solid line, double dashed line. This is a circular bubble are individual measurement instrument such as transmitter, sensor, detector, etc. Now when this shape having a single line inside, this indicates that it is inside the main control panel. When the shape is having double line inside, it indicates that these instruments are placed in the auxiliary control panel. this auxiliary control panel might be placed locally. Locally means in plant. Now what is the difference between this solid line and this dashed line? This solid line indicates that the instrument is installed at the front side of the control panel and it is easily accessible. This dashed line indicates that it is installed at the back side or rear side of the control panel and not easily accessible. In this case, as two lines are there, so those instruments are placed in the panel and the panel is locally installed. The solid double line indicates that this instrument is installed or placed at the front of the panel and easily accessible. This dashed double line indicates that it is installed in the auxiliary control panel and it is placed at the rear of the control panel or back side of the control panel and not easily accessible. So these are the different instrument bubbles and the explanation what we can get from different types of symbols. Next, coming to instrument identification tags. Every instrument or every equipment have identification tag and the tag is having letters, numbers inside the bubble. See here, as an example here it is written FCV045. So FCV045 is the tag number of this equipment, means tag number of this control valve. These tag numbers are used to designate the parameters being measured and the function performed with that measurement. Typical parameters are flow, level, pressure, temperature, and the typical functions are display, record, transmit and control. There are different parameters which might be identified by different alphabets. Say flow is identified by F, pressure by P, temperature by T, level by L. Others identification letters are also there. I is for indicator, C is for controller, S is for switch, E is for element, T is for transmit, G is for gauge, V is for valve. There are different identification letters starting from A to Z of English alphabets. The instrument tags consist of 2 to 5 letters. The first letter is the parameter being measured. The parameters are normally flow rate, pressure, temperature, level. The second letter are the modifier, whether it is the differential, whether ratio. The third letter indicates the display or the passive function, whether it is using as the alarm indicator, as recorder, as normal indicator or any type of gauge. The fourth letter is used or indicates the active function or output, means whether it is a controller, whether it is a transmitter, whether it is a switch or a valve. The fifth letter is the function modifier. It indicates the high, low, open or close. So any tag number might have 2 letters, 3 letters, 4 letters or 5 letters. Normally the first letter always indicates the different parameters to be measured. This is flow, pressure, temperature, level. The second, third and fourth letter might indicate indicator, controller, switch, element, transmitter, gauge, valve, etc. In the tag number we can see a particular number. Here in this case it is 045. This number indicates the loop number, means in which loop the instrument or the controller is related. There is a chart from where we can get information regarding the different alphabets starting from A to Z, when it will be used in first place, second place, third place, fourth place or fifth place. These are different meaning while the alphabet is at first place. These are different meaning while it is in second place. These are different meaning while it is in third place. This is while it is in fourth place. This is while it is in fifth place. Say for example, this is HIC 045. This is hand indicating controller or hand indicator controller. Is in first place, so it indicates hand. Now I is having first place, third place, So in this case it is not in first place, so I has been used here as a third position, secondary device used as a indicator. Next C, here it is in fourth place, so C is using here as the controlling system. So HIC means hand indicator and controller, or hand indicating controller, and 045 indicates the loop number in which this instrument has been used. Next say T and T. First place is T. T is temperature, and when it is used in another place, here corresponding T, if we look, this is in fourth place. In fourth place T indicates transmit, so this is TT indicates temperature transmitter, and it is related with the control loop 45. PDT. PDT is pressure differential transmitter. Say P. P in first place, this is pressure. Next D. D in second place, this is differential. Next T. T is in third place, it is transmit or transmitter, so pressure differential transmitter. FB. While F is placed in first position, then it indicates the flow, and V, search here, B in fourth position, it indicates the valve, so this is flow valve. So by this way, following this structure, all the tag numbers have a particular meaning, depends whether it is a transmitter, whether it is acting as indicator, whether it is acting as controller, or the combination of those. Now here this is another example, 12 FC135. FC is the flow controller which is used in the control loop number 135, and this 12 is preceded by this tag number. This 12 indicates that it is placed in the area of the process, and the area number is 12. From this example, say these three tag numbers, 12 FC, here also 12 FC, here also 12 FC, but last position is 135A, 135B, 135C. This means that 135 is a control loop, and in that control loop these three controllers are there. These are different symbols for different types of flow measuring instrument: positive displacement, rotameter, vortex, Coriolis, orifice plate, pitot tube, arising pitot tubes, ultrasonic, magnetic, waves, beacon, flume, wire, turbine, target, flow nozzle, venturi, etc. For drawing and designing different P&ID, in the market different softwares are available like eDraw Max, Smart Draw, Visual Paradigm, AutoCAD, MicroStation, Smart Plant, Cadison, Visio, Lucid Chart, Solid Plant, ProCAD, SkyCAD Electrical, etc. So up to this I have discussed about different symbols for the case of different piping equipment and different instruments. These different symbols are normally used for designing and drawing process flow diagram as well as the piping and instrument diagram. Now I am trying to explain a little about a real P&ID, collected it from the net. So I am showing my heartiest gratitude to that teacher who has uploaded this into web. Here see, this is the process flow diagram. There is one vessel, there is one control system having controller, there is one transmitter, and this is the process line. Process flow diagram gives the overview of a particular process with the major equipments. Now when we enter into the P&I diagram of the same system, how it might look. See here, this is the P&ID of same process part. It is too much complicated to explain every part of the drawing. I am explaining here a little about few components in this P&I diagram. When we will work in the field, no doubt we will give more effort and we will learn more about this P&I diagram. I am zooming part of this P&I. We can see here this is the inlet of the process flow and this is the main process line. This main process line having the tag number. Here it is 6 inches. Next P10 1001 A111, and at last it is N. Already I have discussed a little about the meaning of different alphabets in different position. Here at the last it is having N. N indicates that no insulation have been used here. In the next part, it is a reducer 6 inches cross 4 inches, means the pipe diameter has been reduced from 6 inches to 4 inches. This triangular shape indicates that in this place there is a pipe break, means two types of pipes are connected here. See here, it is 6 inches pipe and after that it is 4 inches pipe. This is one ball valve and it is attached with the pipeline using the flange connection. Two vertical lines in both sides indicates that it is flanges. There is a gate valve which is normally closed. There is 1 inch gate valve and which is used as a drain. Here it is written BM. From here we can understand that it is the Venturi meter. This Venturi meter connected with the transmitter is FT101 and it is connected with the control panel instrument FI101. Two gate valves have been installed in both sides of this Venturi meter. This is motor operated butterfly valve which is connected with flange. MOV101 motor operated butterfly valve. This HS101, HS101, these are different hand switches. These are connected with the motor. Here it is written add valve, means it is attached with the motor operated valve and motor can be operated by using this one. Again this motor can be operated from remotely. This HS101, this is at the control panel and signal from this control panel normally comes to the motor to operate this motor operated valve. There is another gate valve which is used here as a drain. Now coming to here, this is another butterfly valve which is piston operated diaphragm type butterfly valve. This valve is actuated by pneumatic signal. This line is defined that it is the pneumatically operated and a three-way valve is here which is used to operate this piston operated pneumatic butterfly valve. Here ZSO102 and ZSC102, these are attached with this valve locally, as well as signal from here might go to the control panel and control panel devices are ZL0102 and ZLC102. Here this three-way valve might be operated from remotely and the remote instrument is here. This is the controller or PLC. From the control room or control panel or from the PLC, the signal comes to operate this three-way valve. This is one triangular shape. This indicates that there is a pipe break here. Here this is one safety relief valve which is attached with the bypass line. This is one gate valve. This is another gate valve which is connected at the bypass line of this piston operated pneumatic butterfly valve. This is tank or vessel having a particular dimension. This tank is having different nozzle and different openings. Here N1, N2, N3, N4, N5, there are different nozzles. Nozzles means different openings. The dimensions of different nozzles are also indicated. This nozzles here indicated is it is having 4 inches. This nozzles is having 6 inches. To operate the process, the different parameters like temperature, pressure, level inside the vessel should be maintained. So some instrumentation part must be here also. See here, this is TE, this temperature element which is RTD. This is LT 103, level transmitter 103. This is LI 103, level indicator 103. LZT, this is level safety transmitter 101. This is PT 103. This pressure transmitter gets the pressure of inside process. The level transmitter, temperature transmitter indicates the level and temperature of the process inside the vessel. Here different temperature sensors have been used in different levels to get the average temperature of the fluid inside the vessel. Because the temperature at different level of the process might be different, so it is better to get the average temperature of the process inside the vessel. All the signals from the pressure transmitter, temperature transmitter, level transmitter goes to the control panel via this tank gauging system. The control panel having different indicators and different controllers also. Signal from the level safety transmitter goes to the remote indicator or remote controller also. Everywhere in the diagram we can see that there is a tag in every pipeline. Say in this case this is 1 inch pipeline. Coming to the output side of the vessel. Here this is one manual operated gate valve. This is one motor operated butterfly valve. There is one safety relief valve which is connected at the bypass line of this gate valve. In this motor operated butterfly valve, having the facility of this ASS 107B, 107C, these are attached with this valve, and locally we can operate this valve by using these switches. Similarly, can be operated remotely by using controller from the control panel. We can get the status of the position of the control valve by using ZS107 and ZL107A. We can see here that all the instruments connected with a particular control system or particular control loop are identified by a unique number. In this case, we can see here it is 107A, it is 107B, it is 107C, it is 107, it is 107, it is 107A. From this we can easily understand that these all are related with this part. This part means related with operation of this motor operated control valve, which is having the tag number MOV107. So these are few explanation of few equipments and instruments in the P&ID. Again, I am telling that when we will work in a plant, we will give more effort to understand this P&ID, and it is the most important part as an engineer. I believe from this discussion we get at least a little idea about the piping and instrument diagram.